Hello everyone. So let us see another doubt. In a soccer practice session, the football is kept at the center of the field, 40 yards from the 10 feet high goal post. A goal is attempted by the kicking the football at a speed of 64 feet per second at angle of 45 degree to the horizontal. Will the ball reach the goal post? So what are the information given here? A player is doing this soccer practice, means he is kicking the ball with his leg, and the ball is kept at the center of the ground, and the goal post is 10 feet high, and the separation between the center and the goal post is given 40 yards. This 40 yard. So first we have to convert the all the given parameter into same SI unit of system. Same unit of system, we are going to take SI. So let us first convert 40 yards into feet. So 40 yard is equal to 40 into 3, that is 120 feet, right? And the projection is how much? Projection speed is, the value of u is given 64 feet per second, and the angle of projection is given 45 degree with the horizontal. This angle of projection is also given here, that is theta is 45 degree. So for this equation we have to use the equation of trajectory. What is the equation of trajectory? Y equal to x tan theta 1 minus x upon r. I will prove it later also. How does it comes? Y equal to x tan theta. In this, y gives the height of the object when it is at distance x along the x-axis. So we are going to use this. So for first we have to find the range. So what is the value of range in this situation? So range equal to u square sine 2 theta upon g, and g we have to use here 32 feet per second square. We don't have to use 9.8 meter per second square because everything is given in feet per second and feet per second square. So the range is going to be 64 into 64 and sine 2 into 45 into g, that is 32. So this 2, and the value of r is going to be 128 feet. So obviously that this ball is either going to hit the goal post, or like it can go from top of the goal post. There are two possibilities. The ball can go like this also, and it can fall on the ground, or it can go like this and hit into the goal post. So the question is asking, will the ball reach the goal post? Means the question is asking, will the ball reach inside the goal post? The height of the goal post is how much? 10 feet. It is given, right? So we have to see the what is the value of y at x. X equal to how much? 120 feet. This is the value of x. So let us try to find the value of y at x equal to 120 feet. So the x is how much? 120 and tan 45. 1 minus the x is again 120 and the range is 128. So the value of y is how much? 120. This is 1 and this is 128. 128 minus 120. So the value of y is 120 into 8 upon 128. So this we can cancel with help of 16 and y equal to, this is 40, so how many times this, 120 upon 16, that is 4, then 30 upon 4, or that is 7.5 feet. So when the value of x is 120 feet, the value of y is 7.5 feet. So the answer for this question is yes. The answer for this question is yes. The ball is going to hit inside the goalpost. Okay. Now, how this equation comes? So let us see the proof of this equation of trajectory. Many students, they use another formula for equation of trajectory, but I find that is not useful. This one is quite useful. Let us see how it comes. So, like, let us project an object at angle theta with initial velocity u. This is your x-axis, and this is your y-axis. So ux, the x component is how much? U cos theta, and the y component is how much? Uy, u sin theta, u sin theta, u sin theta. And the acceleration due to gravity along the x-axis is 0. The acceleration due to gravity along y-axis is minus g. Because I have taken up as a positive, then down as negative I have to take. That I have to follow the proper sign convention. At any instant of time, let's say particle is here. So there is some position of x and there is some value of y. So equation of trajectory basically relate the relation between the x and the y. Okay. So at any instant of time, the value of x is how much? The value of x is uxt plus half axt square. We have to use the equation of kinematics along the x-axis, and the acceleration along the x-axis is 0. So only we have to take the uxt term, that is u cos theta into t, and the value of t is equal to x upon u cos theta. This is the first equation. At any instant of time, the value of y is how much? The value of y is u by t plus half a by t square. What we have to do? We have to use the equation of motion separately along the x-axis and separately along the y-axis, keeping the time common for both the axes. So the value of y is here, the uy is u sin theta and t, and this is going to be minus half gt square because ay is minus g. And let us put the value of t, then the value of this u sin theta and t is, that is x upon u cos theta minus half c and t square, that is x upon u cos theta ka square. Okay, so this u gone cancel, and x tan theta minus z x square upon 2u square cos square theta. Okay, now like I have to multiply and divide sine theta above and below. That I can do, right? Same thing we can multiply and divide. So sine theta upon 1 cos theta, that there is cos square theta. So 1 cos theta I will use. So sine theta upon cos theta, that will give tan theta. Then the value of y, and the x is common in both the expressions. So I can take x tan theta as a common. Then the remaining thing is left is 1 minus g x upon gx upon 2 u square sine theta and cos theta. So y equal to basically x tan theta 1 minus x upon g I will take down, and this u square 2 sine theta cos theta. So 2 sine theta cos theta, that is going to give you sine 2 theta, and upon g. This is the expression for the range u square sine 2 theta upon g. So the value of y is equal to x tan theta 1 minus x upon r. So always use this formula of equation of trajectory. Okay.